Hey everybody, here we go. Lesson 9.5, slope-intercept form. This is just part one. We're going to keep it simple and then pick up on part two on Monday. All right, here we go. We've been talking about linear relationships. Okay, relations, right, are just groups of ordered pairs. All right, so you're pairing up one member of one group and one member of the other group, and you're making these ordered pairs. And as we've looked at those, we've seen some patterns, and the special pattern we're focusing on right now are ordered pairs that form a straight line when you plot them on a graph. We also know that these linear relationships also have a constant rate of change and a slope. So now we're going to get a little bit more focused on a special way to write equations for linear relationships. All right. And as you get deeper into algebra, you'll notice that there are three important forms that you can write linear equations in. Any linear relationship can be written in these forms, and you can like alter them, adjust them, and change the form without actually changing the relationship. You can move terms around, or solve for a certain variable or whatever. But these are our forms. So what you're going to do is you're going to copy this down and write these forms in your notes. So the first form, and the one we're going to be focusing on today, is called slope-intercept form. That's y equals mx plus b. All right, the second form is called standard form, and that's ax plus by equals c. It's important to make the a, b, and c capital. All right, and the final form is point slope form. Y minus y1 equals m times x minus x1. All right, and these are all good for different reasons. All right, they're all used in different situations, maybe a different real life situation or a different type of problem solving that you'll have to do. They're good for different reasons. We're going to be focusing here on slope-intercept form. And also notice that each of them has an x and a y, right? That's your ordered pair right there. That all the ordered pairs would satisfy these equations. All the extra stuff, like the m and the b in slope-intercept form, the a, b, and c in the standard form, and the y1 and the m and the x1 in the point slope form, all those are just going to be constants in your when we actually use them. They're just kind of placeholders to show you the form. All right, and there will be numbers in their place when we actually have the equations. All right, that's enough. But this is the one that we want to focus on today, slope-intercept form. All right, also, sorry, last thing. If you have an equation in one of these forms, you can always modify it to make it into another one of the forms. All right, let's check it out. Okay, go ahead and pause and copy down the key concept from page 412 in your textbook. All right, and you'll see what we're getting at here. All right, go check that out. Copy down the key concept, and then let's get ready to go. All right, copy these down. We've got real-world situations that lend themselves to slope-intercept form. All right, so let's read through these. Number one, you start with $100 in the bank and save $25 per week. So if we were to think about the independent and dependent variables here, we would realize that, let's see, the amount of money you have in the bank, the total you have in the bank, depends on the number of weeks that passes. All right, so y would be the total, and the number of weeks would be your x value. All right, y would be your total, yeah, and x would be the number of weeks that have passed. All right, well, how would we write that? So you could have an equation here, y, your total amount of money, equals, you have 100 to start with, and then you're increasing that at a rate. So Mr. Woodruff's way to say it would be, I would say you go like this, 100 plus 25x, right? X being the number of weeks that have passed. But slope-intercept form says you're just going to flip that around. 25x plus 100, okay? So this is slope-intercept form, and you'll see that a lot of these types of problems where you have a starting amount and then it's increasing by a certain amount per something. All right. So here we have another example. The plumber charges $50 plus $21 per hour. So the total charge for the plumber would be Y. And that total charge is going to equal, well, you have to pay $50 up front, and then you're constantly adding a certain amount per hour. So 21, and then we're going to multiply that by the number of hours. So the total cost Y depends on how many hours the plumber works. All right. So what if the plumber just shows up? Just shows up. Well, you call them over. They show up, and then you say, "Oh, you know what? I fixed it. Sorry. Thanks for coming." How much are they going to charge you? They worked 0 hours. If you said they'd still charge you $50, you'd be correct because they still had to get in their car and come. They didn't work any hours, but they got $50 just from showing up because you didn't call them in time to stop them from showing up. All right, so that is how that works, and we can flip that around to be 21x plus 50. 21x plus 50 would be in official slope-intercept form. All right, so there's that initial fee, and then there's that constant rate of change that is in the equation. All right, last one, there are 30 gallons of water in the tank. It's leaking 2 gallons per hour. All right, so the total amount of water is going to be Y. And that depends, the amount of water depends on how many hours. Now this 30 is decreasing constantly every hour. So X will be the hours, and we're going to decrease that 30 by 2 every hour. So if it's 1 hour, it'd be decreased by 2. If it's 2 hours, it'd be decreased by 4. If it's 3 hours, it'd be decreased by 6. All right, but we're going to just rewrite that. All right, and 30 plus negative 2x, and we can rewrite that as negative 2x plus 30. All right, so I just want to give you a context to these problems so they're not just kind of out of the blue. All right, let's go to the next page of our notes. Okay, this is your slope, and this is your y-intercept. Slope, y-intercept, slope, y-intercept. Remember, slope is your rate of change. How are the two variables changing in relation to each other? Okay, well, this is pretty simple. We're just going to find the slope and the y-intercept. That's it. Okay, for these 4 equations, go ahead and try that. What's the slope? What's the y-intercept? All right, ready? Slope for this one is going to be, what's the slope? Slope is 2. And what's the y-intercept? It's 5. All right. Okay, so if we have y equals mx plus b, all right, the m is always your slope and the b is always your y-intercept. Now, remember, the y-intercept is a point at which the line from this linear relationship crosses the y-axis. So you can always write that as a coordinate pair as well. So if it crosses at the y-axis at 5, it would cross at the point 0, 5, right? Don't go anywhere from the origin left or right. Go 0 left or right, but just go straight up on that y-axis 5. All right, so that the y-intercept is a point that you can plot, okay? And then that slope, we can always think of that as a fraction of 2 over 1, which means that that's going to be a rise of 2 and a run of 1. All right, and we'll talk about that more in lessons to come. All right, so I'm just, instead of writing slope and y-intercept, I'm just going to write m and b. All right, so for number 2, the slope would be 1/4. Right, the number next to the variable, the coefficient as we call it. All right, and then we've got a y-intercept. Now we could just go like this, use the definition of subtraction to make sure we realize that that is a negative, or we can just see, well, when it's -6, it's going to be a negative y-intercept. Okay, and what point would that be? That if we wanted to plot it, it'd be at 0, -6. Keep it going. M equals -3. Remember, we can always write our slope as a fraction as well. And our y-intercept is going to be 7, and we can always think of that as a coordinate 0, 7. Last one. Uh-oh, this one's weird. That's why I put this little star here. All right. Well, if there's nothing there, then it's like the identity property. What will I add but not change the value? Ah, okay, plus 0. So the slope is 4, or we can say 4/1. And the y-intercept here is 0, meaning that it goes through the point 0, 0. And what do we know about lines that go through 0, 0? Right? It's going to be a direct variation. Going to be a direct variation because it's a straight line through the origin. And we know that because it's got that nice format, y equals mx, which we learned in the previous lesson. All right, so making all those connections. Okay, next, this is where it gets maybe a little tricky. All right, but state the slope and the y-intercept when the equation is not in slope-intercept form. Well, we got to manipulate these equations. So we have 4 problems, and we want to isolate the y. Isolate the y, and then manipulate the terms so that it looks like y equals mx plus b. We need y on the left side. We need the x term first, and then the constant term second on the right side. All right, so we just need it to look like y equals mx plus b. So in this case here, we need to isolate this y here. We got to get it by itself. So we have an extra term, the negative 4x. So we're going to add 4x and add 4x. That cancels that out. Yay, y is isolated. And then we have 2 plus 4x. Those aren't like terms. Now we're going to use commutative property and just move those around. So we have 4x plus 2. Now, easy to find. Once it's in that form, it's easy to find the slope and y-intercept. So m is going to be 4, or 4/1, and b is going to be 2, or 0, 2. All right, so that's our answer. But to get there, we had to put it into slope-intercept form. Okay, try this one on your own, pause it, and then go for it. All right, here we go. We got y. We got to isolate that y, right? We got to get it by itself. So we're going to subtract the term over here, minus 6x. We got y equals, we're going to have negative 3 minus 6x. Now, I'm going to use the definition of subtraction so that now I can use commutative property and flip-flop these terms. So negative 6x plus negative 3. And now we can find, once it's in slope-intercept form, we can find the slope, which is going to be negative 6, or negative 6/1, and b is going to be negative 3, or 0, negative 3. All right, I think we should be getting pretty good at this. Now, y is right here this time, so we have to get rid of that extra term, the minus 5x. We're going to add 5x. Y equals, now we don't have like terms here, so we just gotta rewrite it like this. We can't combine them, and then we use commutative property and flip those around. And our slope is gonna be 5, or 5/1, and our y-intercept is gonna be 10, or 0, 10. All right, last one. A little different. All right, I'll have to pause and come back after the alarm. And I'm back. Here we go. So we have to isolate that y. There's an extra term, the minus 5. We can add that 5 and add that 5. This one brings up a nice little reminder. We got the negative x plus 5. When there's just a negative symbol out front of an x, all right, we can slide in a 1 there. And then we can find our slope, which is going to be negative 1, and our y-intercept, which is going to be 5. Remember, slope can be written as a fraction, negative 1/1, and the y-intercept can be written as a coordinate pair, 0,5. All right, well, I believe that's all we have today. Hopefully the lesson is chunked well for you so you understand it. It's always a beautiful day for math. Woodworth, out.